Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafiq bin Ibrahim. My metric number is 10DTK23F1034. So now I will be presenting about an of-chapter semiconductor device. So now we will begin with question 2. The question is, you are working in a laboratory tasked with testing the performance of full-wave rectifier circuit designed for converting AC input to DC output. The rectifier circuit is connected to a 12 VRMS 60 Hz AC power source. Your supervisor asks you to measure and examine the output voltage waveform across the load resistor. First one is, draw the equipment and connection you will make to measure the output voltage waveform and of the full wave rectifier circuit, and label all the equipment. Then, draw the input and output of the waveform. Lastly, from the waveform, calculate the output voltage. The solution for the question 2 is, for the first one is, draw the full wave rectifier bridge, and when you draw, you have to include the transformer, AC power source, diode, and also the resistor and ground. From the draw, you can see the transformer connected to a AC power source, which is 12 BRMS and 60 Hz. And for the right side, you can see the transformer also connected to the diode, and the diode we have to use a 4 diode. You can see the diode also connected to the resistor and the ground. So the second one is, you have to draw an input waveform and output waveform. From the diagram, you can see there's some difference about input waveform and output waveform. The third one is, in order to calculate the output voltage, you have to find the VP first. To find the VP, you can use VRMS formula, which is VRMS equal to VP per square root 2. As you know, we already got VRMS, which is 12. So we will just put in the formula, which is 12 equal to VP per square root 2. So the answer for the VP is 16.97 voltage. So now we can calculate the output voltage using the formula VP minus 0.7. So the VP is 16.97 minus 0.7, and we got 16.27 voltage for the output voltage. So now we will continue with the question number 3. The question is, you are a technician tasked with testing a bipolar junction transistor BJT to verify its pin configuration and functionality. The transistor is labeled as an NPN type. Your objective is to correctly identify the emitter, base and collector pin, and ensure that the transistor operates according to its specification. Demonstrate the setup and the procedure you will follow to identify the emitter, base and collector pin of the transistor. So the answer for this question is, the first one, you have to set your multimeter to the diode test mode. This mode is typically indicated by a diode symbol on the multimeter. Then you have to test each pair of pins. Place the multimeter probe on one pin and the black probe on another. Note the reading on the multimeter. A reading that shows a voltage drop, usually between 0.5 voltage to 0.7 voltage for silicon transistor, indicate a forward bias diode. Repeat this for a combination of the 3 pins. Then identify the base. The base will be the common pin in the 2 pair that show a voltage drop when forward bias. Last one is to identify the emitter and collector. The emitter will typically show a higher voltage drop than the collector when forward bias with respect to the base. And that's it. Thank you.